Hi, this is Nimla Rednam. In this video, we are going to start exercise 5.4 from NCERT textbook class 8. In the previous video, we looked at long division method in order to find the square root of a given number. So, in this exercise, we are going to be dealing with the finding the square root of a given number, right? So, here, let's look at the first question. We have find the square root of each of the following using long division method. Okay, so let's take up the first question. 2304, right? So I'm going to take down 2304. So this is exercise 5.4. First question, we have to find the square root using long division. Now, if you remember, we discussed that in order to find the square root, we are going to pair up the digits starting from the ones place. Okay, so this is my pairing, right? And now we look at the first bar, which is 23, and we want the closest perfect square to 23, which is less than 23. You know that 4 square 16 is less than 23. If you take 5 square, you'll get 25, which is more than 23. Okay, so now I'm going to subtract these two. So here I have 7, right? Now I'm going to bring down the next bar, which is 0, 4. So the number I have is 704, and here I'm going to have double of 4, which is 8. Okay, and I need to figure out what should be the next digit. So you can clearly see 81 into 1 is too small. 81 into 1 is 81, and it is really small compared to 704. So you can see that actually, because they're asking us to find the square root, means it's a perfect square. So if the ones digit is 4, okay, what squares, it is a square, right? Because I'm having 1 into 1 here, or 2 into 2, 3 into 3, so on. So which will give me 4 in the ones digit? 2 square will give me, but 82 into 2 is again very small. So the next perfect square, which has 4 in the ones digit, is 8, correct? 88 into 8 is 8, 8, 64, 64 plus 6 is 70, so 704. So that is going to be my next digit, 8, right? And then I have a 0. That means the square root of the given number 2304 is 48. Okay, and we have used long division in order to solve the sum. Okay, now there are 11 more bits which we are supposed to solve using the same long division method. So what I'm going to do is I will be solving these in a similar video that I have uploaded for 5.3 for the additional sums. Okay, so now let's move on to the second question. Find the number of digits in the square root of each of the following numbers without any calculation. So now I only need the number of digits. I don't want the square root. I'm just interested in the number of digits in the square root. Okay, and we have already seen how to do this. Here I have 2 digits. So which is an even number. So half of that 1. So the square root has 1 digit. Here I have 3 digits, which is an odd number. So I'll add 1 and then divide this entire thing by 2, which is 2. That means the square root of the number 144 is a 2-digit number. Here I have 4 digits, which is a even number. So directly take half of that. So the square root of 4489 is a 2-digit number, right? And here I have 5 digits. So because it's an odd number, I'm going to add 1 to it. And then if you take half of that, you're going to get 6 by 2, which is nothing but 3. So here again, the square root of the number 27,225 is a 3-digit number, right? Here I have 6 digits, which is even. So directly I will take half of that. So again, the square root of 3,90,625 is a 3-digit number. Okay. So that way you will be answering directly whenever the question is about the number of digits in the square root of a given number. Okay. So that is your second question. Next, in the third question, they're asking us to find the square root of the decimal numbers. They didn't mention long division method, but clearly we are going to use long division method for this. Okay, I will do the first bit and the rest of them in the upcoming video. So 2.56, let's look at that. I have 2.56, right? So third question, I have 2.56. The first step is always the regarding the bars. I'm supposed to put the bars, right? So here I have a decimal. So as we discussed earlier, before the decimal, the bars are going to go in this direction, and after the decimal, they are going to go in this direction. Okay. So here I have only one digit, so I'll place a bar above 2, and here above 56. Okay. Now 2. What is the perfect square closest to 2 and less than 2? It is 1. 1 square is 1. Okay. Now take the subtraction of this, you will get 1. And then I'm going to bring down 56. Before that, I have to place the decimal here and then bring down 56. So now I have 156, right? And here I already have 2 times of 1, which is 2. Now I have to find out what is my second digit, right? So here I have 156. So 1 is clearly not going to work. 21 into 1 is way too small, right? Now, as I said, whenever they're saying find the square root, that means that you can assume for now that the given number is a perfect square, right? So I'm interested in a number over here such that its square ends with 6. We know that that is true for 4. 4 square 16 and 6, which is 6 square, is 36, right? So we'll check both of them. 4 into 4 again is too small. You will have, something in 90s. So I'm going to take 6. Okay, 6, 6, 36. And that's it. We have our answer. So here I'm going to place 6 over here. And I have 156 and the remainder is 0. Therefore, square root of 2.56 is equal to 1.6. Okay. So that is how you will solve the sums whenever you want to find the square root of a given decimal number. Next we have find the least number which must be subtracted from each of the following numbers so as to get a perfect square. Now if you remember in the theory part of this, I already told you, usually in the question they are going to ask either multiply a given number, what is the least number that it should be multiplied by or divided by to make it a perfect square, in which case we use prime factorization. But whenever they are asking about adding something to it or subtracting something to it, you have to use long division method, and we are interested in the remainder. Okay. So here least number which must be subtracted from the given number. So I'm going to do the long division method and look at the remainder. Okay. And also find the square root of the perfect square that you have obtained, which is easy, very simple, because you'll already have the quotient from your long division method, and that is your square root. Okay. So let us write down fourth question. I'm going to take the first bit, which is 402. Okay. Fourth question. I'm going to proceed with the long division method. Start pairing them, starting from the ones place. So the first bar is 4 and the closest perfect square to that is 2 square. So I'm going to write 2 2's. Okay. And I will have the answer 4. And then subtract these two, I will get a 0. I'm going to bring down the next bar, which is 0 2. So now here double of 2 is 4. Okay. Now what should I put in this, as the next digit over here? If I put 1, 41 into 1 will become 41, which is greater than 2. Okay. So the only option I have is putting 0 here. Correct? So that means I'll get a 0 and the remainder happens to be 2. That means I am going to subtract 2 from the given number to make it a perfect square. What do we mean by that? If I subtract 2, then I will not have this 2 here and I'll get a remainder 0. And once I have a remainder 0, I know that the given number is a perfect square, right? So the answer is I need to subtract 2. And what is the square root? of the numbers so obtained, which is nothing but the quotient here, which is 20, right? So this is how you are going to solve the sums when they're asking you the number that has to be subtracted from a given number to make it a perfect square, right? Let's move on to the next question. Fifth question. Find the least number which must be added to each of the following numbers so as to get a perfect square. Again, also find the square root of the perfect square. Again, first of all, we will be doing long division and then I'll explain what we are supposed to do with that. Okay, so let's take the first question, 525. Right. So here I have 525. Long division method, first step is pairing up. And then look at the first bar 5, closest perfect square is 4, which is 2 square, right? So if I subtract this, I get 1. Next bar is 25, bring down 25, right? Double of 2 is 4. Okay. Now here 41 into 1 is 41, too small, right? And if I look at 43 into 3, it will become 129, which is higher. So I need 42 into 2. Okay. And I'm going to write 42 into 2 is 84. Okay. And what is the remainder here? I have 1 and I have 41 is the remainder. So what are we going to do from here? Is the remainder going to be helpful to me in any way? If you remember in the previous sum when we had to find the number that has to be subtracted, we were interested in the remainder, right? But here looking at the remainder is not really going to help me. I want to know what should be added to 525 to make it a perfect square. What we will be looking at here is the quotient. Okay. What is the quotient? 22, right? That means that 22 square would have given me a remainder 0, right? Can I say that then that 22 square, whatever be the value, I need not find it out, 22 square is less than 525? Is that correct? 22 square, can I say that 22 square is less than 525? Yes. That means that the next perfect square after, the adjacent perfect square to 22 square is clearly 23 square, right? That means that whatever is 23 square is going to give me a clue of what should be added to 525, right? So let me find out 23 square, right? So here I have 9, 2, 529 is 23 square, which by now it should be noted to you. So 529 is 23 square. That means I'm going to write it equal to 529 here. That means what did I add to 525? I've added 4, correct? If I add 4 to 525, I'm going to get 529. So therefore, I have the answer. What should be added? I'm going to add 4. I'm going to add 4 to 525 to make it a perfect square. And what is the square root of that? I already have the answer here, 23. Right? 23 square is 529. So square root is 23. This is how we are going to solve the sums when we want to add something to make it a perfect square. Next question. Now we have 4 word problems here and then we are done with the chapter. Sixth question. Find the length of the side of a square whose area is 441 square meters. Okay, so we already know the formula for area of a square, right? You know that area of a square is side into side. Okay, and they're saying that this area is given as 441 meter square, right? And now they're asking us what is S. What are we going to do? You're going to take square root on both sides. Okay, taking square root on both sides, I can say that S is nothing but square root of 441 meters. Okay, and what is 441? Like I said, it should be noted to you, but I'm going to do the long division method quickly. And in the exam also, you must be showing the long division method to arrive at the answer. Okay. So I have 2 2s 4, and next bar is 41. Twice of this is 4. 41 into 1 will give me 41. Therefore, the square root is nothing but the quotient over here, which is 21. So the answer is 21 meters. Okay, that is your sixth sum. Let's look at the seventh sum. I have, in a right angled triangle ABC, angle B is given as 90 degrees. Okay. If AB is equal to 6 centimeters, if two sides are given, can you find the third side? Here, whenever you have a right angle triangle, we are going to be using Pythagoras theorem, and using that you will get the third side when you take the square root of AC square. Similarly, here also we are going to do the same thing. Let's do that. So let's take a new page. So here I have ABC right angled at B. Okay. So I'm going to write it as question number 7. Okay. So the right angle is going to be marked B. Right. So by now we are very familiar with Pythagoras theorem. Right. So I know that AC square is equal to AB square plus BC square. Right. Now, what is given to us? We have AB as 6 and BC as 8. Okay, I'm going to substitute these values. I'm going to write AB as 6 and BC as 8. Right? So AC square is equal to 6 square plus 8 square. Okay. Now 6 square is, and the units are centimeter square. 6 square is 36, 8 square is 64, and the sum is 100. And now I want AC. Simply take square root on both sides. I'm going to get AC as square root of 100, which is 10 centimeters. Okay. So this is the first bit. In the second bit, they have given the hypotenuse. The hypotenuse AC is 13. One of the sides is 5. Okay. So we are going to write 13 square is equal to AB square plus 5 square. Okay, now I'm going to take this to the other side. AB square is equal to 13 square, which is 169, minus 25. 5 square is 25, which is nothing but 144. Now taking square root on both sides, I will write AB as square root of 144. Here again, it's centimeter square on both sides, right? So I have 12 square is 144. So the other side, the unknown side, is 12 centimeters. That is your seventh question. Next, coming to the eighth question, a gardener has 1000 plants. He wants to plant these in such a way that the number of rows and the number of columns remain same. Find the minimum number of plants he needs more for this. So what should we add it to 1000 to make it a perfect square? So I'll read the question again. A gardener has 1000 plants. He wants to plant these in, in such a manner that the number of rows is the same as number of columns. Okay. For this, what is the minimum number of more plants he needs? So if the number of rows is equal to number of columns, it becomes a perfect square, right? And in order to make it a perfect square, what has to be added? How many, he's saying minimum number of plants he needs more for this. So I'm interested in what needs to be added. Okay, in either case, I have to do the long division. So let us start. Take 1000 and do the long division. Pair them up. Okay, and the first bar closest perfect square is 9. So 3 square is 9. and if I subtract, I will get 1, bring down the 0. Double of 3 is 6. Okay, now what should I put next? If I put 62 into 2, it becomes 120 something, greater than 120. So I will stick to 1. Okay, so 61 ones are 61, and this, when I subtract this, I'm going to get 39. Now what has to be added? I'm interested in the quotient, not the remainder. Here I'm going to say 31 square is less than 1000. So 1000 is clearly less than 32 square, right? And what is 32 square? 32 into 32 is, if you do the multiplication, you're going to see that the 1024. 32 square is nothing but 1024. So what should be added to 1000? So if I have 1000 plus 24, it gives me 1024. So what is the answer? 24 should be added. Okay, 24 should be added. And what is the, they didn't ask the square root. Clearly they wouldn't ask the square root, right? So find the minimum number of plants he needs more for this. So the answer is 24. Now this brings us to the last question, ninth question. There are 500 children in a school. For a PT drill, they have to stand in such a manner that the number of rows is equal to the number of columns. How many children would be left out in this arrangement? So you're subtracting something. Some children are left out. So you're subtracting from this 500 something to make it a perfect square. Why is it a perfect square? Because number of rows is equal to number of columns. So they're talking about perfect square. So take the number 500 and we'll proceed from there. So let's take 500. Do it here. Okay. Bars. Closest to 5 is 4. 2 square is 4. Subtraction gives me 1, and here I have next bar is 0 0, twice of 2 is 4, and now 41 into 1 is 41, 42 into 2 seems to fit 84, very close, right? So I'm going to take 42 into 2, 84, and the remainder is 16. Now here these many children are left out. They're asking about what should be subtracted from 500. So I'm interested in the remainder, which is 16. So the answer is 16 children are left out from this particular drill, right? So with this, we come to the end of chapter 5, which is squares and square roots. Of course, I'll be uploading a video showing the remaining sums like we have done for exercise 5.3, because there's no explanation part there. It is just numericals for your practice, and you can go through that video for reference, right?